Hi, I'm Cassie, and I'm going to walk you through question 5 of the AAMC Physics Question Pack. So at first glance, this question seems a bit dense. It seems like you need to understand what photodiode detectors are and what they do, but that's not really the case. What you really need to understand here is that we're talking about light, and light is a type of wave. So as a quick review, what is a wave? Well, a wave is just a way of transferring energy from point A to point B. And there's no transfer of matter here. It's just a transfer of energy. And for the MCAT, there are two types of waves that you should be familiar with: mechanical waves and electromagnetic waves. So this question is talking about light, and light is an example of an electromagnetic wave. Let's make a quick table to review the difference between electromagnetic and mechanical waves. So first, what are examples of electromagnetic waves? Well, we just said light is an example. But remember, we have the whole electromagnetic spectrum here as I pasted in. Now, you should be familiar with this spectrum for the MCAT. You should know where the different types of waves fall within the spectrum. So for example, you should know that radio waves here on the left side of the spectrum are longer wavelength, but shorter frequency waves. And over on the very extreme on the right side of the spectrum here, we have gamma waves, which are super high energy since they're high frequency waves. And somewhere in the middle here, we've got our visible light spectrum. Okay, so these are types of electromagnetic wave that you need to know for the MCAT. But still, like, what is an electromagnetic wave? Well, an electromagnetic wave is just a collection of perpendicular electrical and magnetic fields that are traveling through space. Like I said, a wave just transfers energy from point A to point B. So in this case, you're transferring that energy from A to B through these oscillating perpendicular electrical and magnetic fields. Now, electromagnetic waves, do they need a physical medium to travel through, like air or water? No, they don't, because they're not actually moving any matter, right? They're not actually vibrating air particles or moving water. They're just traveling through space. It's just energy traveling through space. So oftentimes we'll talk about electromagnetic waves that you can travel through a vacuum. Now, what about mechanical waves? Mechanical waves are going to be things like sound waves. They're also going to be things like water waves, seismic waves, etc. So how do mechanical waves transfer energy? Well, they actually are going to move particles. Remember, mechanical means associated with motion. So mechanical waves are going to vibrate particles. That means that they have to have a medium to travel through, because if they don't have a medium, if you're just in a vacuum, there's nothing for them to vibrate, and therefore they can't travel. So mechanical waves, how do they transfer energy? Through motion, specifically through vibrating particles, which of course inherently means that they need to have a medium to travel through, like air or like water. So now that we've reviewed what a wave is and what our two main types of waves are that we need to know for the MCAT, let's talk about what interference between waves looks like. Interference between waves just means that the waves are going to come together and that they're going to affect each other. And they're either going to add together their amplitudes or they're going to cancel each other out. So let's take a look at the different cases between how waves can line up and interact with each other. So let's start with a 0 degrees phase difference. What does that mean? It just means that our two waves are going to be exactly lined up. So remember, we can visualize a wave as a sine curve. So let me go ahead and draw my sine curve here. Our sine waves, they always start at the origin at 0, and then they look like this to do one full cycle. So at the origin, we say that this is 0 degrees. So consider a full cycle is 360 degrees, just like a full circle. So we start at the origin, which is 0 degrees. At this peak of the wave, this is going to be 90 degrees. When we get back to the origin, that's going to be 180 degrees. When we dip below the origin to our trough, the low point of the wave, that's going to be 270 degrees. And when we get back to the origin, that's going to be 360 degrees again. So if we want to have a 0 degrees phase difference between our waves, well, that just means they're going to be exactly on top of each other. So if my red wave is my second wave, it's going to look like this. So what happens when waves line up in this way? Well, we get a special kind of interference called constructive interference. And constructive interference essentially means that the two waves are going to add together to construct a wave that has twice the amplitude of the original wave. So remember that the amplitude of our wave is the distance between the wave and the x-axis. So the amplitude of our red wave would be here, for example. And the amplitude of our black wave would be the exact same thing here. If we add these two amplitudes together to construct a wave with twice the amplitude of our original wave, let's go ahead and draw that in blue. Then our new wave is going to look something like this. So it has double the amplitude of our original wave. So you can think of constructive interference like you have two rowers in one boat, and those rowers are moving exactly in sync. So they're rowing forwards at exactly the same time. the result is that the signal, or the power that's propelling the boat forward, is going to be twice what either of the rowers on their own could produce. That's the same idea here. The two waves become twice as strong in amplitude as either of the waves were alone. So that's constructive interference. Two waves come together with a 0 degrees phase difference, also known as being in phase, and they construct a wave that has twice the amplitude of the original waves. Okay, now what if we have only a 90 degrees phase difference between our waves? Well, if we draw our first wave here, we said the origin is going to be 0 degrees. So this is going to be 0 degrees. And this peak here is going to be 90 degrees. So if our waves are 90 degrees out of phase, we're just going to shift that second wave to start at the 90 degrees of the first wave. Okay, so if we draw that second wave in red, it's going to start right here. And then we just make the normal sine wave like that. Okay, so what do you think is going to happen when these two waves come together? Well, here, instead of our amplitudes adding together, they're going to sort of partially cancel out. So our resultant wave is going to be a wave with an amplitude that's smaller, than either of our original waves. So our resultant wave is going to look something like this. It's going to be a wave with an amplitude, right? So remember, this is the amplitude that's smaller than either of the original waves because they sort of cancel each other out. So you can think of this partial interference like you have two rowers in a boat and one is rowing forward and the other one is not rowing forward at exactly the same time. So the result is that the boat's still going to move forward, but it's going to move forward a little more slowly than it would if the two rowers were exactly in sync. Now, what if we have 180 degrees phase difference between our waves? Let's take a look at this bottom left corner. Well, if we draw our first wave, now our second wave is going to be 180 degrees over from the first. If the origin is 0, the peak is 90. If we come back to the origin again, that would be 180 degrees. So our second wave is going to start, if we draw it in red here, right here. Okay, and if we were to backtrack on the wave, it would look like that, right? Now, what do you notice? These two waves are essentially exactly canceling each other out. So this amplitude in black is a positive amplitude. So let's just say this is an amplitude of, I don't know, +2, right? Well, our amplitude in red below the origin here is going to be maybe an amplitude of -2. So what happens if we add +2 and -2? We get 0. So our resultant wave here is going to have 0 amplitude. It would just be like, essentially walking along our x-axis here. So this is the case of what we call destructive interference. Destructive interference is when two waves are 180 degrees out of phase. They exactly cancel each other's amplitudes out, so there's no resultant wave, or the resultant wave has, an amplitude of 0. Now you can think of this like if one rower is rowing forward and the rower behind him is rowing backwards at the same time, then that forward motion and that backward motion are going to cancel each other out and the boat's not going to go anywhere. There's going to be 0 amplitude for the signal. Okay, lastly, let's take a look at what would happen if our waves were 360 degrees out of phase. So we said 360 degrees would be over here, right, on our wave. So that means our second wave is going to start at the end of this first wave. So it would look like this. Now, if we backtrack along that second wave, we're going to exactly trace over our first wave. So in other words, this is the exact same case as a 0 degrees phase difference, meaning that our two waves are actually in phase, even though they have, quote unquote, a 360 degrees phase difference between the two. So any multiple of 360 degrees means that our waves are going to be in phase. And that's going to be, again, the case if we were to draw the resultant wave here. You should know that this is going to be a wave with twice the amplitude. It's going to be a case of constructive interference again, just like we had in the original case. So this question specifically asks about when our waves of light are going to experience destructive interference. Well, after walking through this, we know that it doesn't really matter what type of wave they are. Destructive interference always happens when there's 180 degrees phase difference between our waves and those amplitudes cancel out. Okay, so what are our most important takeaways from this question? So our number one takeaway is just going to be, what is a wave? And a wave, we said, is just a way of transferring energy from point A to point B. Then we talked about what our two main types of waves you should know for the MCAT are. The first are electromagnetic waves, and that's like the waves in this question, or light. Okay, so we have our whole electromagnetic spectrum that you should know for the MCAT. So this is going to be things like light, like radio waves, etc. And the interesting thing about electromagnetic waves is that they don't need a medium to travel through. Because they're just oscillating perpendicular electrical and magnetic fields, they don't actually move any particles. Therefore, they can travel through a vacuum. Then we talked about what mechanical waves are and the fact that they're things like sound waves, like water waves or seismic waves. And these waves, they do need a medium to travel through because since they're mechanical waves, they need to move something. And the thing that they're going to move are going to be particles. It can be air particles, water particles, etc. Then we talked about our 4 cases of how waves can interact with different phase differences. Our first case we talked about was that of constructive interference. And they said that's going to occur when we have a 0 degrees phase difference between our waves, which also, you can also say that the waves are in phase exactly or perfectly lined up. And what happens in that case? Well, the amplitudes of the 2 waves, they just add together. So you get a resultant wave that has twice the amplitude of either of the original waves. So basically you construct a wave with a larger amplitude. And then lastly, we talked about destructive interference. And we said that that occurs when we have 180 degrees phase difference between our waves. And so they're out of phase by 180 degrees. And what's the result? Well, our 2 waves are going to destroy each other, essentially. So you have a resultant wave that has 0 amplitude. So I hope this helps. Feel free to leave comments if you need any clarifications or have any questions, and check out my other videos.